So one of the things that's really important for these problems is that you must be able to translate between the different forms of the first fundamental theorem. First, you have to be able to identify that one function, it can be a number of different ways that it can be written, that it's the antiderivative of another function. And this can be told you in several different ways. One, it can just be directly stated. Capital F of x is the antiderivative of lowercase f of x. But it can also be told to us in another way. We can be told that one function is the derivative of another, which implies that one function is the antiderivative of another. So we could also be told that the derivative of capital F is f of x, which means if one function is the derivative of another, that means the first function is the antiderivative of the second. We could also be told we have f and f prime, which means f is the antiderivative of f prime, and so on and so forth. Anytime that we're told that something is the derivative of something else, we can also state it backwards, that something is the antiderivative of its derivative. If we know that capital F of x is the antiderivative of lowercase f of x, then we have to be familiar with all the variations on the first fundamental theorem. So we know the integral from a to b of lowercase f of x dx equals capital F of b minus capital F of a. But we can also go the other way. If we're told that we want to find f of b minus f of a, those are capitalized, that's the same thing as doing the integral from a to b of its derivative. We also need to remember that this can be thought of as the change in capital F of x from a to b. So if we're asked about that, or if we know that, that's what it's talking about. And we have to remember that this can also be thought of as the area under the f of x curve from a to b. So we have to keep those things in mind when we're working with problems like the following. Oops. So the function g of x and its derivative g prime of x are continuous on the interval from 2 to 6 and have the values given in the table below. What is the value of the integral from 2 to 6 of g prime of x dx? So the first thing that we're going to do is we're going to write the relationship. We know that g of x is the antiderivative of g prime. And once we clarify that, we can write the fundamental theorem. So right here, the integral from 2 to 6 of g prime of x dx is going to be the antiderivative of 6 minus the antiderivative of 2. So once we have that, g of 6 we know right here. It's in the table. It's 1. G of 2 is right here. It's 3. Voila. The problem is not a difficult one. It's only the tricky part is figuring out, this tells you that one function is the antiderivative of another. That means you can use the first fundamental theorem and just do some substitution. The tricky part is realizing that you actually have the tools, even though it's not straightforward.